Hi everybody. I had a request for like a review video pertaining to, sorry, I've got my phone going here as like my dot cam, so it's gonna look a little awkward here for a second, but I had a request for like a review video to go over some questions from section 7.7. That's the story problem one where you have to set up your own system of equations and then solve. So I'm just gonna run through a few examples. So just a few quick notes. All right, so I'm just looking at like a preview of what the homework from that section looks like. I'm not going to run through any examples of the beginning because I think the better use of time would just be to look at questions where you have to go through the whole process of solving. So, but I will say that the first few questions are a good way to kind of like prime your brain to like, figure out how to solve like the intermediate steps. So for example, the first question's asking for like the amount of pure acid that is in a given solution. So for example, 60 ounces total, they will basically want you to find 20% of 60, then 25% of 60, 30% of 60, 50% of 60. That's because you need to use that sub skill there in order to solve one of the later questions where you're looking at two different solutions combined into one. So I will say these first few questions are good starting points to just kind of like get an idea of what sort of things you're going to have to do and some of the skills you got to like combine together at the end for some of these bigger problems. So I would definitely check those out if you're having a hard time with this section. So I guess that would be number one. Number two, I would say is pretty good. I would just encourage you to draw a picture. So I'll go ahead and at least set this one up real quick. So I'm going to stop sharing now. I'll go ahead and use my dot cam, which is just my cell phone. But all right. So if you look at the question here, we're talking about an official playing field, and I'm assuming we're talking about a rectangle. And so an official playing field, including end zones for the Indoor Football League, has, so I'm going to read this as I draw it, because I like to draw as I read. So an official playing field, which we're going to assume is a rectangle, including the end zones, but Indoor Football League has a length, so here's my length, that is, so is typically means equals 29 yards longer than. So 29 yards longer than means 29 plus the width. That's what the question says. And then, so I'm using W as my width, which means I probably should put the W down here where the width is actually at. And I'm going to note here, one of the first things you want to do whenever you have a story problem is to label your variables like as soon as possible. So, and I would make sure you include units in your labels for your variables because that'll help you understand what your final answers actually mean. So length in yards, width in yards. And if you're not sure what your variables should be, then your variables are typically going to be like if you look at the goal of the question, then your variables should basically be the result of what the question wants. So for example, if I'm not sure what my variables should be, I'm just going to look at what does the question ask me to do. It says find the length and the width. So in my brain, that should tell me, all right, my variables should be length and width if possible. I'm not going to say that's always the case that you can do that, but I would say 90% of the time whatever the question's asking for, that's what your variables should be. So that's what I did here. They want length, they want width. I have a variable for each one. And so from here, when you have two variables, that means you need two equations, well, or more, but typically you just want to use two. So when you have two variables, that means you need two equations. So I actually have one equation right here already. And again, an equation has an equal sign. So if I have an equation here with length and width in it, then that's half the battle. The other equation, I have to kind of like use some prior knowledge here. So they did give me the perimeter of the rectangle. So the perimeter is 142. Again, that's from the problem here. And then find the length and width. So that's all the information they gave us. So using what we know about rectangles, we know perimeter is going to be two lengths and two widths. There are obviously different ways you could do that. So perimeter equals two lengths plus two widths. Some people might write this as 2 times the length plus the width. Either way is fine. And so at this point, whichever version of this you want, I typically use the top one, but you can use the other one if you want. Now, I already have a number for the perimeter, so I'm going to get rid of that P, and I've got a 142 there. So let me clean this up. I've got two equations now. Length equals 29 plus W, and I also know that 142, the perimeter, equals two lengths plus two widths. So at this point, the system should be pretty easy to solve. I'm actually not going to spend time solving it. Just that way I can spend some more time on some of those tougher ones. But for most people, I would suggest using substitutions. You have one of your variables on their own already. So all you have to do is substitute 29 plus W into that L in the other equation. Because what this is saying is anywhere you see an L, it's exactly the same as 29 plus W. So I'm going to get rid of that L and replace it with parentheses with 29 plus W. But then I got to finish the rest of that equation. So now we've got something in one variable, and we can solve for W. Once we get W, we plug it back into probably the top one. That's the easiest. And then that'll give you L. And then again, we've already defined our variables ahead of time. So once you figure out W and L, you should be able to look back up here to figure out, all right, what do these actually mean? And then you can type them in. So that's just kind of a quick rundown on how to set up a question like that. Don't be afraid to draw a picture. That's why I picked this problem, because I think pictures are worth 1,000 words or 1,000 numbers, however you want to think about that. We're in a math class. So anyway, don't be afraid to draw a picture. I'm going to move ahead to a question like I just saw number 4 here from the homework. Looks like it had to do with some triangles, which they drew the picture for you. But yeah, so again, this is one where you need two equations, and they kind of give you hints here. So one of the equations should have to do with the sum of all the angles on the inside of the triangle. So basically x plus y plus 90 has to equal 180. That's one equation. And then supplementary angles have a sum of 180. So in case you didn't know, supplementary literally means they add up to 180. So in case you forgot some geometry, these two angles form a line, and I think some of us might remember a line means 180. So if not a big deal. But anyway, so y plus this little angle right next to it, these two angles would have to add up to 180. So that's what they're talking about with supplementary. So this y and that angle are supplementary. Adding those together to equal 180 would be your other equation. So that's just like a quick setup for that one. I'm going to move on to number 6. Again, I might not solve this one all the way, but I'll just kind of talk through how you would use this particular type of strategy. So when solving mixture problems, we call these, sometimes it helps to use a table, which is what Pearson kind of did for you to help get you set up with some of these earlier problems. They're starting with a 20% solution and a 10% solution. So I'm just going to copy down their chart here. Now, remember, the first thing you should do is figure out what is the goal of the problem. So they want to know how many gallons of the 20%. So that should be one of my variables. I'll just call that X for simplicity purposes. So X equals gallons of, now I could write the 20% solution because that's the name they're using in this problem, but as soon as I start putting numbers within the name for my variable, then I think that leads to some confusion. So instead of naming it the 20% solution, I'm going to call it the strong solution because it's the higher of the two. So gallons of strong solution. And then we'll call Y the gallons of, in this case, it's the 10% solution, but I'm going to call it the weak solution. So now I already know what is the goal. I need to figure out X and Y. Once I have X and Y, I can look back here and know, okay, X is gallons of the strong stuff, Y is gallons of the weak stuff. So I think that helps a lot of people just to like have the goal in mind right away. And so they did give us a table, and these tables help some people quite a bit. Some people don't like tables, and that's okay. I'll do an example where you don't use a table. But they do try to teach you how to use these tables early on. So gallons of solution, I didn't really give myself enough room to write. Percent as a decimal. Definitely did not give myself enough room to write. And then gallons of pure alcohol. So this is a problem where like number one, practicing number one will help prepare you for solving this because number one basically teaches you how to fill out this last column in the table. All right, so they actually they did define X and Y for us, so I better make sure my definition matches how they put it in the table. I should have looked ahead about that. So let's see. They put X in the column with the 20%. Okay, so ours does match. So the strong stuff has a percent of 20%, which I'm just going to put as 0.2. They did write the 20%, but I'm just going to skip that part of it so I don't clutter up my table. So X is 20%, Y is 10% alcohol. And then, all right, the original problem asks us to mix them together to get 10 gallons total. So when I'm thinking of total solution, that's the left column. That's what that means. So 10 gallons total. That's, all mixed together. And they want so this is the strong, weak, and then the bottom row is when they're combined. So when they're combined, we want it to be 19%, so 0.19. And so if you practice number one, then that'll help you fill out this last column pretty easy. So the bottom row might actually be the easiest one to start with because if we have 10 gallons and 19% of those 10 gallons is pure alcohol, then number one taught us that number one in the homework taught us all we have to do is multiply these two values. So 19% of 10 is found by taking 0.19 times 10, which would give you 1.9 gallons of pure alcohol that are existing within the 10 gallons of the mixture. So what this means is 1.9 gallons of alcohol are in here, and then the other 8.1 gallons is probably just water or something. So that's what this means. Now, we don't have concrete numbers to do that with in this left column. So, but we're still going to be consistent because we know that whatever we have here for X, whether it's 10 gallons, 15, 20, whatever that number is here, we're going to multiply it by 0.2 to tell us how much pure alcohol is there. So 0.2 times x is what goes in that right column. And then same thing here, 0.1 times y will tell us how much pure alcohol is sitting in that weak container. All right, so from here, we can come up with our two equations pretty easily now. Now, the middle column, we kind of ignore at this point, so we're going to look at the left column. And if we just kind of, try to use our common sense, we know that if we have gallons of strong stuff plus more gallons of weak stuff, adding gallons and gallons gives us a total number of gallons. So we know that adding x and y needs to be a total of 10. So that's our first equation right here, x plus y equals 10. And then over here, this right column is in the same format, except it's talking about pure alcohol now. So, for example, if x was 5, then 20% of that would mean that 1 gallon out of the 5 is pure alcohol. And then similar here, we don't know what exactly the numbers are going to be, but pure alcohol plus pure alcohol needs to be a total of 1.9 gallons in the final combination. So this expression and this expression are going to actually represent gallons of alcohol. And so we want alcohol plus alcohol to be a total of 1.9. So that's where I get my other equation, 0.2x plus 0.1y equals 1.9. And so those are your two equations. And at this point, I would probably use elimination to solve. Substitution would, I don't know, depends on your preference. I would say substitution elimination might be equally as easy, but I'll do elimination for this one just because we already talked about substitution on the last one. So elimination would be where we want to find one of the variables and try to get their coefficients to be the same value, but just opposite signs. And I think the easiest way to do that, it really doesn't matter. I'm going to definitely use this top equation. I'm going to eliminate my y's, I think. So in order to do that, I need my y to have a coefficient of negative 0.1. That way when it adds with positive 0.1, it'll be 0. So I need to multiply this whole equation by negative 0.1. All right, so then I'm just going to rewrite everything over here. So, but remember, this has to go to everything. So negative 0.1 times x is negative 0.1x. Negative 0.1 times y is negative 0.1y. Then negative 0.1 times 10 is actually just negative 1. We got some nice numbers here. If you get good at this, you might be able to figure out the more strategic way. Like, I picked y on purpose because I anticipated these numbers to be really easy. I didn't really feel like multiplying 0.2 by 0.2 basically. So when you get good at this, then you can find out the easier ways to solve these. So I didn't do anything to the second one because it already has the coefficient that I want, and I don't want to change it again. So once I get here, elimination says we add, like the best way to do this is just to add these equations together. So, and I've already got my like terms stacked on top of each other. So what I've got is negative 0.1 plus positive 0.1 is 0. So I'm just going to circle a 0 through there because I have 0 y's now. Now for my x's, negative 0.1 plus positive 0.2 is positive 0.1x. And then negative 1 plus 1.9 is just going to be positive 0.9. And so if I divide by 0.1, then I get x to be 9. And remember, x is in terms of gallons. So 9 gallons of the strong stuff. Now all we have to do to find the weak stuff is to, pick one of these first two equations that are easiest to use. I really like this first one because remember we need x and y to be a total of 10. We already know x is 9. So we're going to subtract 9 and, we're going to subtract 9 and we end up with 1 gallon for y. And then obviously just make sure you pay attention to which part of the question you enter these into. Remember, X is the strong stuff, so that would be where they ask for the 20%. And then Y is the weak stuff, so that's where they ask for the 10%. So that's it for now. I'll post another video with a couple more examples from this section. So I'm going to close out of my phone here. And I will see you guys in the next video.